Solve the following system of nonlinear equations graphically. Round your answers to two decimal places. Y equals e to the x plus 1 and 2x plus y equals 3. So here I have two equations. One of them is exponential, and exponential functions that aren't shifted vertically have a horizontal asymptote at the x-axis. This one is shifted over to the left by 1 unit, so there's this point here, which normally is on the y-axis, but shifted over, and has this sort of shape here, although I'm not being terribly accurate with how quickly that increases. I just want to give an idea of what's going to happen here. Then we also have the line 2x plus y equals 3, which is equivalent to y equals negative 2x plus 3. So that's a y-intercept of 3 and then a slope of negative 2. So it would look along these lines here. And we can clearly see that there should be one solution to this system. But even given the sketch that I've done here, it doesn't appear that the solution is going to land on any integer values. So it's probably unlikely that there's going to be an algebraic solution that we can come up with. And there's sort of a hint to that here for us. It says, round your answers to two decimal places. And that tells us a pretty decent hint that what we're going to have to do is solve this using some sort of approximation method. Now, the calculator is what we'll use for these approximation methods. The way we do this is we put the two equations into y1 and y2. So e raised to the x plus 1 power for y1 and negative 2x plus 3 for y2. Now I'm going to hit zoom and choose the standard zoom. That's just negative 10 to positive 10. And we basically see the same situation here. All right, now to determine where this intersection point is, because the intersection point is of course the solution to the system, what we need to do is use the function second calc, so hit the trace button and that takes us into the calculate menu, and we're looking for the intersection point between two curves. Now it just wants to know what's the first curve, what's the second curve, and it will automatically default to y1 and y2. And the initial guess, you just need to move your cursor close to that intersection point. And what it will do is, to as many decimal places as it can, provide the solution, the approximate solution to the system. So in this case, that's 0.06 and 2.88. So my solution here is 0.06 and 2.88. And that's going to be the only solution because the line's not going to come back around and intersect with this curve ever again. So we're safe in saying that's the only solution. But the one thing I want to mention is when you are trying to come up with that, be careful not to just move your cursor around on screen and try and just get it close to that intersection point and use that as your approximate values, because whereas that is approximately the solution, it's not accurate to the number of decimal places required. In order to get that to happen, even the trace feature doesn't allow you to get that close. You do need to use second calc and allow the calculator to go through its algorithm in determining what that value is.